Hi kids, facing issue with circle chapter of class 10? Then you need to watch this video. In this chapter, we'll discuss about the angle properties of circle, the cyclic properties of circle, and the secant and the tangent properties of circle. In this particular video, we'll discuss all the theorems which are there in angle properties of circle. We'll derive them or we'll prove them. And trust me, if you know the theorems properly, you can do all the sum on your own. Okay, so let's get started. Before going to the theorem, let us see some terms which are related to circle which we should know. Actually, we have done those in class 9. Now suppose this is a circle. We know what is a circle. Collection of all the points on a plane, suppose A, B, C, such that its distance from a fixed point O, which is known as the center of the circle, is same. Which means if you talk about OA is equal to OB is equal to OC, as many points as you can take, okay? And this distance is known as the radius of the circle, okay? Now, a line segment having its end point on the circle is known as the chord, and the chord which passes through the center. Suppose I'll draw a chord over here, see, it passes through a center, that is known as diameter. Now this curved portion is known as your arc, and the region between the arc and the radius, this region is known as a sector. Now look carefully again, this region is your minor sector and the other region is your major sector. Okay, sector is the region bounded between the arc and the radius. Okay, now the region bounded between the chord and the arc, this is known as segment. This is known as segment. Again, we'll have, suppose this is your minor segment and this is your major segment which contains the center of the circle. Now two more important points I should say. Second, a line which cuts the circle at 2 points. Suppose this was PQ. It intersects the circle at 2 points. This PQ is known as the secant. Okay? And the most important is a tangent. What is a tangent? A tangent is a line touching the circle at 1 point only. Suppose there's a point Y and you draw a line in such a way that it just meets the circle at Y, then this, suppose MN, is your tangent. I hope these terms are clear. Now let us look at the first theorem. Look at the first theorem, which says that the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part. Which means if this is your circle, suppose this is the center O, you take an arc AB, suppose with AB, you join the center, this is your angle. So this angle will be twice, angle AOB will be twice the angle subtended by it at any point on the remaining part. Suppose we have another angle with the same arc AB on any part of the circle, suppose ACB, then AOB will be twice ACB. So if this is 50, this will be 25. Let us prove this. See what I'll do. I'll join CO. Now look carefully. Triangle OAC. I'll just prove it. Triangle AOC, if you see, OC and OA are equal. OC is equal to OA, which means this is an isosceles triangle. So this angle and this angle will be equal. So angle OAC will be equal to OCA. Suppose x. So this is x and this is x. Now look carefully. If you look at angle AO, suppose this is M, then angle AOM will be sum of interior opposite angle, exterior angle. Remember, in a triangle, exterior angle equals to sum of opposite interior angle, will be equal to x plus x, which is x plus x, which is twice x. So this is 2x. Similarly, in this triangle, if you see, if I take OBC, triangle OBC, in the same way, OC and OB are same. OC equals to OB, which means this angle and this angle will be same. Suppose this is y, this is y. Let OCB is equal to OBC equals to y. Let then definitely this angle BOM will be equal to y plus y. Same. Exterior angle equals to sum of opposite interior angle. So this will be 2y. Now look carefully. Angle ACB is nothing but x plus y according to our construction. And angle AOB is equal to 2x plus 2y. 2x plus 2y, which is equal to 2 taking common, x plus y. And x plus y is nothing but angle ACB, twice of angle ACB, isn't it? Which means angle at the center, which is AOB in this case, will be twice angle at any point on the remaining part of the circle, that is AC, angle ACB in this case. Okay, so just remember, angle at the center is twice the angle at circumference, you can say. So if this is Z, this will be 2Z. If this is 50, this will be 100. If this is 20, this will be 40. Okay. This diagram at times is drawn like this also. Look. This is your circle. Suppose this is your center and the point over here and B. A and B. Then this, suppose, then this is your angle at circumference. Suppose this is Z and this is your angle at the center. This will be 2Z. Okay, don't take this angle as 2Z. Angle at the center in this case will be reflex AOB and angle at the circumference is ACB. So AOB will be twice of ACB. Clear? These two diagrams are same. Just the AB points are at the different places. Okay. Now look at the next theorem. Now look at number 2, which says that angle in the same segment of a circle are equal. Which means if I have a circle, if suppose I take an arc AB. Okay, with this arc, if I draw, angle at the circumference, suppose ACB, and the same arc, if I draw another angle on the circumference at a different place, suppose this, then these two angles will be same, suppose D. Then angle ACB will be equal to ADB. That's the theorem. Angle in the same segment. See, the arc is AB in both the cases. Okay, it's fixed. Then only we can say same segment. So these two angles are same. The proving, I think, is very simple. What? We have done the first theorem. Suppose this is your center. Then, yeah. We know. We just did one theorem which says that angle at the center is twice the angle at the circumference with the same arc. So see, with AOB, suppose is x, then ADB will be x by 2 by the first theorem. Similarly, ACB will be again x by 2 because angle at the center is twice the angle at the circumference, isn't it? Which means angle ADB will be equal to angle ACB. That's the proving. Then the segment has to be same, nothing like this. Look over here. If you say, suppose this is your A, this is your B, then suppose this is X, and you take another angle. See, but the segment has changed. So this angle and this angle, you can't say whether they are equal or not. Okay, if the segment is same, see, in this case, then these two angles are same. Clear? Now let us look at the next theorem. Now look at this one. Angle in a semicircle is a right angle, which simply means, suppose you have a circle and this is your diameter AB. Okay, this is the center. Then with AB, okay, if you form an angle at any point on the circle, suppose this, then angle ACB is equal to 90 degree. Angle in a semicircle is a right angle. How can you prove this? Very easy. Any point, if you draw here also, you know, this angle again is 90 degree. If you draw here, again this angle is 90 degree. Okay, now how do you prove this? Very easy. Look, angle, the first theorem which we did, angle at the center is twice the angle at circumference. So we can say angle AOB. Angle AOB is twice angle ACB. ACB, see the segment is same, AB, AB. Now we know AB is a straight line, so angle AOB is 180 degree, will be twice of angle ACB. So this is 90 equals to angle ACB. So this angle will be 90 degree, as well as this angle, or you talk about this angle, all 90 degree. Clear? Very easy. Now look at the next theorem. Now look at this one. If an arc of a circle subtends a right angle at any point on the remaining part of a circle, then the arc is a semicircle. It simply means, suppose you have a circle, okay, you take an arc AB, okay, I take this arc, see the dotted one, then with this arc, if you make an angle, suppose ACB, such that ACB is 90 degree, then this arc AB is a semicircle. Pretty easy. Suppose the center of the circle was O. So I am joining AOB. I don't know whether it's AOB is a straight line or not. Okay, I need to prove that only. Okay, look over here. Then this is the angle at the this is the angle at the circumference. This is the angle at the center, and we know by the first theorem, angle at the center is twice the angle at circumference, which is twice into 90, which is 180, which simply means if this angle is 180, AB is a straight line. AB is a straight line, and if AB is a straight line passing through O, simply means AB is the diameter to the circle, and if it's the diameter, then definitely this part is a semicircle. That's the theorem. So in angle properties of circle, we'll use all these theorem while doing the sum. Just a recap. First one, angle at the center is twice the angle at the circumference, which means if this is x, this is 2x. Okay. Next one we did was angle in the same segment are equal, which means with AB, if I draw an angle, suppose ACB, another angle as suppose ADB, then these two angles are same. Then we did one more. In a circle, that if AB is the diameter, so with AB, if you draw any angle, that angle will be 90 degree. Clear? So based on these theorems, let us solve the first exercise of this chapter. angle properties of circle. Now look at this sum from exercise 15.1, sum number 1, part 1. They have told us to find the unknown x. Look carefully. Angle ACB and angle ADB will be equal. Why? Angle in the same segment. ADBC, AB, AB, they will be equal. Angle in the same segment, isn't it? Which means you can say this is 50 degree equals to angle ADB. So this angle is 50 degree. Now look at triangle ABD. In triangle ABD, 42 plus x plus 50 will be equal to 180. Angle sum property. We know this. Okay. So x will be what? 180 minus 92. That's 88 degree. Done. Pretty easy. Write the theorem. Okay. In brief, in short. Angle in the same segment. Now, part 3 if you look. Again, they have told us to find the unknown x. Look carefully. Angle ADB. Angle ADB is equal to ACB. Again, the segment is same. AB. Angle in the same segment. Angle in same segment. Which means this angle is 20. Now, this angle, suppose this is O. COA is 90. So COB will be 90. Angle COB will be 90. Linear pair. Because these two angles add to give 180. So if this is 90, this has to be 90. Now in triangle, look carefully, OBC, x plus 90 plus 20 equals to 180. That's angle sum property, which means x equals to 180 minus 110. So x equals to 70 degree. Pretty easy. We use the same theorem, that is angle in the same segment are equal. Okay. Now look at the next one. Now look at this sum. Part 1. Pretty easy. If you look at the diagram, O is the center, which means AC is the diameter. They have told us to find the value of x. Now look at angle ABC. Angle ABC will be 90 degree. Why? Because AC is the diameter. So this portion is a semicircle. Angle at a semicircle. Angle at a semicircle is 90 degree. Remember, if this is your semicircle with this diameter, if you form any angle, it will be 90 degree. Over here AC was the the diameter. So with the diameter, if you form an angle at any point, that will be 90 degree. Okay. Now look, angle A, suppose this was D. Angle ADB. Angle ADB will be equal to ACB, same segment, which is x. Angle in same segment. Angle in same segment, isn't it? So if this is x, this is x. Now look at triangle ABC. In triangle ABC, x plus 40 plus 90 equals to 180. Angle sum property, isn't it? So x will be what? X will be 180 minus 130, that's 50 degree. Done. Pretty easy. Okay. We first use angle as a semicircle, and then same segment, and then angle sum property we can do. Okay. Look at this one. Okay. I just name it. Suppose this is A, B, C, D. They have told us to find the value of x. Pretty easy. If O is the center, we know this. Look, OA equals to OB in triangle AOB. OA equals to OB. That's the radius, isn't it? Which means angle OBA, angle OBA will be equal to angle OAC, angle OAC, isn't it? So this is 62 degree. Pretty easy. This is 62 degree. Now look carefully. We can do, BCD. Look carefully. Angle BCD and BAC will be same. 62. Why? Angle in same segment. Angle in same segment. Just wait. BCD and BAD. Sorry. BAD. Yeah. angle BCD, BAD. See, the segment is same. Hence, these two angles will be equal, which means angle BCD, which is marked as X, will be equal to 62 degree. No doubt in that. First of all, by isosceles triangle, we got this angle and this angle and this angle are equal. Angle in the same segment. Okay. Now look at part 3. Now, they have told us O is the center. They have told us to find the value of X. Look carefully. This angle first. Suppose this is Y. Then if you look carefully, Y plus 80 plus 130 will be equal to 360. Angle at a point. Angle at a point, isn't it? Which means Y will be 360 minus, this is 210, isn't it? So Y is 150. Now look carefully. Angle AOB. Angle AOB will be twice angle ACB. Isn't it? Angle at the center. Angle at center is twice angle at circumference. We have done this theorem, which means y is what? 150. 150 degree equals to twice of x, which means x is 75 degree. That pretty easy, isn't it? We used all the 3 theorems, I think, over here. Angle at a semicircle, angle at same segment, and angle at the center is twice the angle at the circumference. Okay. Now let us look at the next sum. Now look at sum number 3, part A. They've given this circle, O is the center, BAO is 30 degree, BCO is 40 degree. They have told us to find angle AOC. Pretty easy. Just look over here. We have to find this angle. If this angle we know, our work is done. Because this angle is twice of this angle. Look carefully. I'll join BO. Join BO. Suppose this is X and this is Y. So look at triangle AOB. Triangle AOB. AO is equal to OB. That's the radius, which means X will be equal to 30 degree. This angle and this angle will be equal. Isosceles triangle. Similarly, if you look at triangle COB, triangle COB, same. OC equals to OB, which means Y equals to 40 degree. Y equals to 40 degree, isn't it? In a isosceles triangle, the angle opposite to equal side are equal, isn't it? We know this. So angle ABC is nothing but X plus Y, that is 70 degree. Now we know this theorem. Angle AOC will be twice of angle ABC. See, angle at the center is double the angle at the circumference, provided the arc is same, AC in this case. See, angle at center is twice angle at circumference. Okay, do write the reason. Okay, so angle AOC will be twice of 70, that is 140 degree. Done. Okay, very easy. We use the property of isosceles triangle, and then angle at the center is twice the angle at circumference. Look at this one. They've given the circle, O is the center, angle AOC is 130 degree. They have told us to find angle ABC. Look carefully. This angle first. Reflex angle AOC will be 360 minus 130. That's 230, isn't it? This is 230. Now remember, angle at the center, which is angle AOC, which is reflex AOC, will be twice angle at the circumference ABC. Angle ABC. Remember, this angle and this angle. Don't be mistaken that this angle and this angle have a relation. No. This angle at the circumference, and angle at the center is this. The reflex angle AOC. Okay. Reason will be same. Angle at the center is twice the angle at circumference. So reflex AOC is 230. So 230 equals to twice angle ABC. So angle ABC equals to 115 degree. Very easy. You just need to know the theorem properly. Okay. Now let's look at the next sum. Now look at this one. 4 part A. In this circle, You need to find x and y. I just name it A, B, C, D. Just look carefully. DAC, angle DAC will be equal to angle DBC, will be equal to 40 degree. Angle in same segment, angle in same segment. See, the arc is same. DC, DC, both the angles, angle DAC and DBC are formed by DC only, the arc DC. So if this is 40, this has to be 40, which means x equals to 40. Done. Now look carefully. Angle BAC, angle BAC will be equal to angle BDC, will be equal to 45 degree. Angle in same segment. See, if this is 45, this has to be 45. No doubt. See, BAC, BDC, same segment, isn't it? Now look at triangle BDC. In triangle BDC, 40 degree, which is x, plus 45 degree, plus y will be 180. Angle sum property. These three angles add to give 180. So y will be 180 minus 85. That's 95 degree. Done. Pretty simple. We use one property only, that angle in the same segment are equal. Now look at that one. 4 part B. Pretty easy. Suppose I name it A, this is B, this is C, this is D. Then definitely this angle and this angle has a relation. Look over here. Angle AOC will be twice angle ADC, isn't it? Angle at the center is twice the angle at circumference. See, y and 120 doesn't have a relation, okay? Y has a relation with this angle. Okay, reflex AOC. X has a relation with angle AOC, that is 120 degree. Angle at the center is twice angle at circumference, isn't it? Which means AOC is 120 equals to twice angle ADC, which means angle ADC is 60 degree. Okay? Then find reflex angle AOC. First you find reflex angle AOC will be 360 minus 120, no doubt in that. So this will be 240 degree. Now just look, reflex AOC will be twice angle ABC, isn't it? Angle at the center is twice the angle at circumference. So reflex angle AOC is 240 equals to 2y, which means y equals to 120 degree. Look carefully. Very easy. We just use the property that, the theorem, that angle at the circumference, angle at the center rather, is twice the angle at circumference. Clear? Now let us look at the next sum. Now look at this sum, 5 part A. There's a circle given. They've given angle NYB. If you look at this triangle, 50 degree, and YNB as 20 degree. They've asked for MAN, this angle, and reflex angle MON, which means this angle. Pretty easy. Just look over here. If this is 50, this has to be 50. Vertically opposite angle, angle AYM. Angle AYM is equal to BYN is equal to 50 degree vertically opposite angle. No doubt in that. Now look. ANB, angle ANB is equal to AMB, which is equal to 20 degree. Angle in same segment. Just look carefully. Angle in same segment. Look, with the arc AB, you got the angle AMB, ANB. They will be same. So this is 20. Now in this triangle AMY, angle MAY plus 50 plus 20 equals to 180. That's angle sum property. So angle MAY is equal to 110, and MAY is nothing but MAN. Just look at the diagram, isn't it? MAN, which is this angle only, 110, 10. Very easy. Now look carefully for the second part. Reflex MON. Now, reflex, just look carefully, reflex MON will be twice angle at the circumference with MN as the endpoint. So MAN, see, angle at the center will be twice the angle at the circumference with the same arc MN, isn't it? So angle at center is twice angle at circumference. Now reflex MON, we don't know. Reflex angle MON twice of 110, that's 220 degree. Done. Pretty easy. We use the property that angle in the same segment and angle at the center is twice the angle at circumference. Okay. Now let us look at the next sum. Look at 5 part B. They've given a circle. O is the center. Angle BOA, I think this is A, is 140 degree. And angle OAC is 50 degree. They've asked for angle ACB, which means this angle. OBC, which means this angle. OAB, which means we need to join AB. And CBA. First of all, look at these two parts. Very easy. Look over here. First of all, you find reflex BOA. That will be definitely 360 minus 140. That's 220 degree. Because angle at a point is 360 degree. Now look carefully. BA as an arc. We can say reflex angle BOA is twice angle BCA, isn't it? See, the arc is same. Angle at the center is twice the angle at circumference, remember? So this is 220 equals to twice of angle BAC or ACB is same thing. So 110 equals to ACB. So this is 110. Now look, this we got as 110. Now all the 4 angles of this quadrilateral add to give 180. No doubt in that. So we can say that angle OBC plus 110 plus 50 plus 140 will be equal to 360. All the angles, interior angles of a quadrilateral add to give 360. So angle OBC will be 360 minus, this is how much? This is 250, 300. That's 60 degree, isn't it? So we got this as 60 degree. Done. Then OAB. What I'll do, I'll join this. Okay. OAB, which means this angle. Suppose this is X. Now OA and OB same radius in triangle OAB. OA equals to OB, which means if this is X, this has to be X. Angle in an isosceles triangle, the base angles are equal. Okay. Which means we can say X plus 140 equals to 180. Angle sum property, which means X equals to, this is 40, 20 degree. So this is 20 and this is 20. So this is OAB is 20 degree. Done. Which implies angle OAB is 20 degree. No doubt in that. And the last one, CBA. Now we just got angle, this angle we know, OBC we know, this entire angle was 60 degree. See, angle OBC is 60 degree. So OBC is nothing but OBA plus CBA. Look carefully, that will be equal to 60 degree. OBC is made of 2 angles, isn't it? So OBA is 20 plus angle CBA is equal to 60 degrees. So angle CBA is equal to 40 degree. Done. Pretty simple, okay? We use angle at the center is twice the angle at the circumference. In this video, keep it till here. In the next video, we'll do the rest of the sum. Till then, take care.